Hello everyone. Today we'll be solving house robber problem from Leetcode. So let's go through problem statement. You are a professional robber planning to rob houses along a street. Each house has certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected and it will automatically contact the police if two adjacent houses were broken into on the same night. So given an integer array representing the amount of money each house, return the maximum amount of money you can rob tonight without alerting the police. So we are giving like one array. So let's take example one. So we are given one array 1 comma 2 comma 3 comma 1, and uh, we cannot rob adjacent houses, so we cannot rob zeroth house and the first house. We can do like one zero zeroth and second house and first and third house, and we can also do something like we rob only one house or something. So we need to find maximum number of money we can rob. So let's think about it, about this example. So assume there is only one house. Let's start with base cases. So assume there is only one house. So now the array will look like something one. So since there is only one house, we can do let's check constraint. There is one house. Okay, it's already there. So one house constraint is there. So if there is only one house, you can rob only that one. So let's start from the base. Like if there is only one house, so dot size equals 1, return null 0. So how much, since there is only one house, we can get on the money in that house. So total money is 1 only. If it's 5, it will be 5, its value to the 0th element. And assume there is only two houses. Now says 1 comma 2. So what we'll do, we will take maximum of those houses. So since we cannot rob adjacent houses, so we'll get maximum of those values. So we'll total money will get max of nums 0 comma nums 1. So that would be max of 1 comma 2. So that will be 2. So here as we can see, we can we can get maximum of these values, that would be 2. Now just try to increase the number. So now solve for 3 elements, 1 2 and 3. We are taking this array and breaking down into smaller problems. So this is a way to solve problems using dynamic programming. So we'll be using dynamic programming for that one. So increase one more. So as we already know, if we rob these two houses, maximum we can get 2. So there is one possibility. So let's create one array with the dynamic program, since we are already past the base cases, and also we increase one case. So for the zeroth, if there is only one element, we will have only there is a dp array. We will just initialize it all values with 0. Okay, and here since we can there is only one house, so what we'll do, we'll get only one, and in the second value dp1 will be 2. And here, so if we rob, there are two possible ways. If we rob maximum of these values, so we will get 2. But what we can do, we can skip this house and we can rob this and this house. So initially, so for two cases we will rob only first house, but assume there are one more possible case, we can rob second house and zeroth house. So this way we'll get dp2 is max of dp these values, like first two, so dp1 and current value, so nums 2 plus and here instead we'll get like dp1 and in the next step will be the nums problem a bit harder. So this will be 1 2 3 1, and now we need to find dp3. So dp3 will be maximum of, so here we, if we rob these houses we'll get, let's calculate those values also. So this will be maximum of okay, maximum of dp1 is 2 and 3 plus 1 4, and this will be 4, so dp2 will be 4. So what we'll do, we'll calculate maximum, we'll try to get maximum of these values 1 2 3, how much maximum we get from the robbing these houses. So that is 4, we already calculated, that's pre-calculated value. And nums I, or what we can do, we can get maximum value from these, like maximum money robbed from these plus current house. This will not violate our constraint to rob alternate houses. So this will what this will do, this will be something like nums 3 plus dp so nums 3 is 1 plus and 2, and that is that will get 4. So that is our answer. So maximum money we can get is 4. So if you think about it, there is some kind of formula is there. So what we are trying to do, if we take like bigger example, if we think about entire example, so if we want to get value of this element, maximum money for this element, we can take like maximum value of entire rest of houses, or n minus 2 houses. So what we can get, if we want current max money, so we need to do we can either take two options. So we will take maximum of money robbed in previous okay, let's write in ith term, it will be easier to understand. If we want money from money from okay, let's try to get some other numbers. So ith house, let's make it simple instead of writing long sentences. So for, if you want money for ith house, there are two ways to get it. So either we can get money of I minus 1 houses, I minus 1 houses, raw money of I minus 1 houses, or we can rob like current house. So rob current house plus max money from max money from I minus two houses previous. So this will be like previous I minus two houses, and this will also be uh, previous I minus one houses. So let's apply it to this example. If we want money from this fourth house, let's assume this array is one base, just for easier understanding. If we want value for this fourth house, uh, so we can, there are two possibilities. We'll try to get max of this array, we already know that is 4, or we will get max of this array and plus 1. So max of this array is 4, and for this one it will be 1 plus, and we got this one 2, so that would be 3. So in this case answer will be 4, and we can keep calculating for all the ith element. So kind of we get a formula. So for dpi we'll try to get max of dp I minus 2 norm side plus dp I minus 2, and this will be dp I minus 1. So this is money of previous I minus 1 houses, or we can rob current house and take maximum money from previous I minus 2 houses. So let's try to implement this solution. So we'll declare one array dp with size n, and all the initial values are 0. So for 0th element we will just directly add non-zero, and for first element for the first element we will take maximum of first two elements. So down 0 comma nums 1, and after that we will iterate over rest of the array. So for int I equal to 2, I less or less than nums dot size I plus plus, and dp. Now we'll just apply this formula. So copy it from here. Okay, so copy it from here and return dp n minus 1, that is like calculated value. So let's try to submit this solution. Just try to run with current examples, then we will submit this. Okay, n is not defined, so not size. Okay, okay, again n minus 1. I should have declared n as size of array. Now I'll just replace this num short size. Okay, here we go. So the first example is working. Let's try second example also. Okay, so looks like the solution is working. Try to submit this solution. Okay, it is faster than 100% of solutions, and memory uses only 6.4%. So let's also analyze time and space complexity. Since we are using only one loop, so we have time complexity of order of n. That is why the solution is so much faster, like faster than 100%. Time complexity order of n, and since we are using one additional array, so space complexity is order of n. So this solution has both time and space complexity order of n. So looks like our solution is working fine. So that would be it for the video. If you like the explanation, please like the video. Also, please do subscribe the channel. Thank you. Bye.